Okay, this is the second quality of service lab. We are going to do the same lab, but with a little difference. We are not going to use access control lists because as you saw in the previous lab, using access control lists for classification can become complex, can become cumbersome, because you have to identify exactly what are the protocol numbers that you want to match, what are the port numbers that these protocols are using, and if these port numbers are random, using access control lists becomes more difficult. So you can avoid using access control lists if you rather use the match protocol command for your class maps. Match protocol is a part of NBAR. So use match protocol because match protocol is a lot more powerful tool. If we examine the Cisco documentation, it says that the match protocol command means that the iOS will use NBAR. NBAR stands for Network-Based Application Recognition to perform that match. So we are going to use NBAR rather than access control list. So let's go and do that. Remember that we have the same scenario here. We are receiving video and we are going to transport FTP in this network. So we'll need to classify video and FTP using NBAR. So I don't have to enable NBAR explicitly. It will kick in as soon as I enter the match protocol command. So in order to see how that happens, I'm going to enable a debug. I'm going to do debug NBAR control plane low in order to see how NBAR kicks in automatically. And then I'm going to create the class map. So let's do class map video NBAR classification, and then I'm going to match the protocol real-time streaming protocol. That's it. I'm going to stop the debug, and then we are going to see how NBAR kicks in as soon as you enter this command. NBAR is used automatically. You don't have to enable NBAR anywhere else. It happens automatically. So let's create the other class map. We have this class map, video NBAR classification. Now we need the FTP NBAR classification because we are going to work with video and FTP in this lab. But I'm going to enable here another feature of class map, which is match any. Match any is an logical OR tool, so we will be able to match several protocols in the same class map. So for instance, we will be able to match protocol FTP and FTP agent and FTP data and FTP secure data. So all the types of FTP traffic will be matched in this class map because we are applying here a logical OR clause. So let's create the marking policy map. So policy map input marking. Let's call it classify. I am using different names than the ones that I used in the other lab just to make things even clearer. So I'm going to match video NBAR classification. And then, oh, sorry, this is class, and then I'm going to actually do the marking. So let's see if I can do a description here. No, I cannot do a description. So we're going to do the marking here with DSCCP AF41, and then let's do class FTP NBAR classification, and then I'm going to do marking DSCCP AF21. So this is how the policy map classify and mark looks like. Remember that these classes are using NBAR. And let's attach this policy map to an interface. I'm going to attach this to my Gigabit 1 interface, which is my local area network interface, where the traffic is coming from the end users, and I am not trusting whatever this traffic is marked with. So this will be my trust boundary. So at my trust boundary, I am going to mark, I'm going to classify and mark. So this is what this policy map will do. So let's issue service policy input classify and mark. So my local area network interface, showrun interface Gigabit 1 has this classify and mark, and this is my trust boundary for this network. Now I have to do policing and queuing. I could do policing here as well. I am not doing that in order to make this clear, but policing is also available on the input. So I'm going to do queuing, priority queuing, and policing in the output. So I'm going to have to create my class maps, class map mark video, and I'm going to match anything that has the DSCCP value AF41, and then I'm going to create my class marked FTP traffic. I'm going to match everything that is marked as AF21. Remember that as traffic has already been classified and marked, it is marked already inside the router. And when this traffic wants to leave the router, it is already marked. That is why I'm creating this class map for traffic that is already marked. This traffic was marked at the input. So let's create the class map, the policy map, I'm sorry, to do priority queue and police. So I could do class mark video. I am going to set it as priority level 2. Remember that 2 is for video, 1 is for voice, and I'm going to provide it with 500 kilobits per second. And then for class marked FTP, I'm going to police it to 500 Ks, and the exceed action will be dropped. This exceed action can be several things. In this case, I'm going to drop the exceed traffic. I could remark it to another value if I wanted to. So this is how the policy map looks like. Policy map, priority queue, and police. So I am going to attach this to the output. This is a policy map that is going to do that is going to work great when traffic wants to leave the router. So at my local area network, I am going to attach this. for traffic that wants to leave the router. So when traffic wants to leave the router, I can do queuing and policing. So that is why I'm using this particular policy map: priority queue and police. So this is how the output works, and this is how the input. I'm going to do classifying and marking at the input. I am going to do classifying, priority queue, and police at the output. I can reuse this policy map for the wide area network interface. So for instance, for the traffic that wants to leave my wide area network interface, I could attach that same policy map. So service policy for the output, priority queue and police. So I have the output queuing, output quality of service for the wide area network interface. So the only thing I need is another policy map for the traffic that is going to arrive into my wide area network interface. So let's create that. I am just going to do policing for this one market video. I am not going to do priority queuing because with the CSRs cannot do priority queuing with ingress traffic. Some other type of Cisco equipment can do that, but CSR cannot do that. So if I try to do priority level 2 here, it is going to accept the command, but it is going to do or yield an error later on. So I'm going to skip that, and for marked FTP, I'm going to do police. What for? Okay, and exit action drop. So that is how this policy map police will work, and I'm going to attach that to the wide area network interface. Service policy input police. So this is how this looks like, and this is how this looks like. So let's fire up here an FTP session. So here's the FTP session going on. So we can examine our policy maps. Notice that I'm going to repeat that. This I use just different names in order to make this a little bit more understandable. But it is practically the same as we did in the previous lab. The only difference is that we're using match protocol for our classify and mark input classifying of our policies. So let's issue show policy map interface UBIT1, which is my local area network interface. I can see rate for video, for marking, and I can see rate for FTP. And at the output, I still not seeing marked video. It will eventually show up because I am seeing packets here. And for FTP, it will eventually show up. So let's start another FTP session here. Okay, so we have two FTP sessions. The video is still being shown. Remember, this is real-time streaming protocol. Let's see JB2 for priority queue and police. For marked video and for marked FTP, we can see traffic. For instance, for marked FTP, we're seeing 700 kilobit per second, and we are already dropping 200 kilobit per second. So this strikes me as odd because I am seeing 200 kilobits per second in the default class. I am not seeing that in the video class. So let's troubleshoot that. Something might be wrong with the video NBAR classification because it's not being classified. RTSP. Let's see here, capture of packets. This is CP0, so RTP is not getting, it's not getting. So probably we'll need to choose another protocol. If I wanted to modify this class map, I will probably want to delete it, but I believe this will not be possible because it is being used. So I will need to go into the local area network interface and detach the policy map, which is classify mark. And then from this policy map, so this is what you want to do if you want to fix your class maps. It is actually not easy because you have to detach them from wherever they are being used. Policy map, classify and mark, then no. So let's erase this class map. FTP is being identified, but video is not. So let's create this match any video and bar classification, and let's see how Wireshark is identifying this traffic. Let's trust in what Wireshark is telling us. Real-time transport protocol, RTP. So let's try to do that. Match protocol. RTP or RTSP or RTP video. So let's create the policy map again. and do the marking. And then let's attach that into the local area network interface. Okay. Now, let's see. It is being marked now, AF41. So let's issue show policy map interface bit 1, and we can see that for input video NBAR classification, we can see right now this is what we wanted to have. And let's see for the wide area network, let's issue a clear counters. So we should see now marked FTP traffic and marked video traffic in a couple of seconds. So this will be marked FTP traffic and marked video traffic, and the close default has 0, which is what we expect. So with this example, you will see that it is still a challenge to actually know exactly what protocol we are going to use with match protocol. For instance, see here, I had to do a guess in order to see whether it was this one or this one or this one, the correct protocol. So in order to avoid that, you can enable NBAR protocol discovery in one of your interfaces. So I'm going to enable this NBAR in my wide area network interface. So I will issue IP NBAR protocol discovery for IPv4. So now NBAR is going to kick in. You are going to configure this manually, and NBAR is going to provide you with information. So now we can issue show IP NBAR protocol discovery, and we will see that what are the particular protocols that are being seen on the interface. So FTP data, RTP, RTSP, and so on. So we can see that RTP accounts for most of the traffic, which is the byte count, and FTP data accounts for most of the FTP traffic. So in this way, you don't have to guess what is the match protocol command that you're going to use. NBAR will tell you. And this is the traffic that we are using right now in our lab: FTP data, RTP, ping, RTSP, ICNP, conferencing. And we achieve that with this command: IP NBAR protocol discovery. That's it.